Hi, welcome to the breadboard. Today we have a new Raspberry Pi compatible competition to review in the form of the LeMaker Guitar. And here's the website that we're looking at right now. It's the first choice of public maker according to the website. Creative modular design, supports Android 5.0 and is a high performance, low price module. It's a small board computer. Let's go have a look at the read more. So the LeMaker Guitar is divided into two pieces. We have a baseboard and we have the processing module on top. If you go and look at a little bit more information on the LeMaker Guitar, this is what the board looks like. Let me just zoom in a little bit here so we can see this a little better. We've got two parts to the board. We have the baseboard, which contains the Wi-Fi, the Bluetooth, the Ethernet, HDMI output, USB 3, USB 2, SD card reader, reset button, ADFU button, and a power button, as well as audio in and out for headphones or something, and infrared receiver, power jack, and we have this little header here, which is for an ADC input. There's two channels, 0 to 3 volts, and then this here is the beginning of a 40-pin Raspberry Pi compatible-ish GPIO header. What I'm going to look at right now for this intro video is the specifications for the LeMaker and potentially bring up a Raspberry Pi specifications and put them side by side to see what we have. The one I have is the LeMaker Guitar. It looks exactly like this. The colors are pretty much the same, maybe a little bit. They're washed out on the picture here. So we have a S500 system on a chip, quad-core ARM Cortex A9 CPU. You got it in a 1 gig or a 2 gig option. The version I have is 1 gig. There is also 8 gigabytes of flash, which means in this case that you can actually put your operating system onto the board without having to use an SD card. And that is the method that I'm going to show you as we go through this initial intro. You get Android and or Linux support for the board, and there are a lot of options to download and install this, either using the onboard memory or a micro SD card. You've got Wi-Fi 802.11b, G, and N and 2.4 gigahertz, and also Bluetooth 4.0. 10100 Ethernet, HDMI Type A, LVDS, LCD display, which is what I will be putting a video together to show you how to enable that once you've plugged it in. 40-pin expansion compatible with the Raspberry Pi. Memory that's built in, a whole bunch of documentation, including the 7-inch LCD. This is the LCD module that I have. Here is a block diagram of the S500 that's the core of the LeMaker Guitar. As you can see, it's quite an extensive set of devices. 4 SPI buses, Ethernet, 2-wire times 4 of them, UART's LCD controller going out to the LVDS connector, TV out in the form of HDMI 4, key controller, sensor in. For the camera, uses a camera that's similar to what's used by the Raspberry Pi. We've got USB 3 controller, USB 2 controllers, DMA Nano ECC controller, which includes the flash memory, I believe, memory card controller, Wi-Fi controller, JTAG, chip ID, SPDIF, PCM times 2, and I2S, which is the audio standard, as well as, of course, the ARM quad-core A9 core CPU with DMA, etc. And then on the peripherals, we've also got the Bluetooth, the sensors, serials, Ethernet, touch panel, analog, and headphone speakers. And that's it. And its size is a little bit bigger than a Raspberry Pi, but it does have a lot more on the board. It does have a nice set of mounting holes so that you can easily put it onto a chassis of some kind or create a little 3D printed case, which I checked on Thingiverse. And there are some 3D cases that you can download that would allow you to mount the LeMaker Guitar board and the 7-inch LCD display, which is pretty cool. So as far as what operating systems are available for the LeMaker Guitar, I've just clicked on the resource button here on the web page, and you can see there are 5 different versions of OS for the LeMaker Guitar. There's Ubuntu, Limuntu, which is actually Debian. It's very, very similar to the Raspbian for the Raspberry Pi. You've got the Arch Linux, and you've got an Android for the LeMaker Guitar, as well as the LeMedia, which is, I think, a Kodi kind of install for the LeMaker Guitar. Anyway, sets it up as a media player anyway. Whole host of documentation, including schematics. This is an open source project, and all of the schematics for both the LeMaker base and the LeMaker main module are available for download. Tutorials on the LeMedia, the 3D models if you want to be able to create your 3D printed case for it, PCB layouts, etc. So they're being quite open with all the information you need to be able to integrate this to other things, or even to create your own, I guess, if you wanted to. But really, at the price, it's not really worth doing that. On the wiki page for the LeMaker Guitar, there we have a whole bunch of links to various things about the LeMaker, including how to use the ADC, the infrared, the microphone, Bluetooth, USB 3, setting HDMI resolutions, using the Wi-Fi, the camera, etc., and the LCD. Now I'm gonna do a separate video for the LCD to show how to get it enabled on the LeMaker Guitar, because I found that the current information wasn't quite as easy as I hoped. And I'm not into recompiling images to download back into the LeMaker Guitar hardware either, so I figured out a way that I can do it without doing all of that, and it seems to work just fine. So I will be making a separate video to show you how to do that. Some of the things that is of interest here is things like the LeMaker Guitar ADC. I've just clicked on that link. There's a header block. It's a 6-pin header on the LeMaker Guitar baseboard, which brings out 2 ADCs. As well as a UART channel that you can use and easily read from the Linux operating system, just using simple things like cat statements using GPIO. And you can read in the analog voltage and convert it, well, it comes in as a 0 to 1024 value, or 0 to 1023 should I say, but you can easily convert that into a voltage, and I'll show you an example of doing that a little bit later using NodeRed. And the same thing goes for things like the infrared. All right, it goes through the infrared, how it works, how to use it, and everything else. I'm not going to be trying this right now in this video, but I just wanted to show you that all of the information is there on the fairly comprehensive wiki.lemaker.org website. So go there, have a look. I'll provide a link to it so that you can have a look at things for yourself. I've used a few of the articles in here to get things like the ADC working and some of the GPIO. I did look in here how to get the LCD up and running, but as I said, if I go in there for the LCD, this is the DTS DTB file that when I go through the LCD video, you'll see me edit a portion of this file. All of these settings for the LCD are already in there and they are correct. But what I had to change, because as you go down here, it starts talking about recompiling this, creating a boot image and everything else. And I don't have the wherewithal to be able to do that. But what I do have is the ability to just change the DTS, remake it back into a binary file, i.e. this from text to binary. Initially it's there as a binary file. You can convert it to text, edit it, put it back, put it in the temp folder, and then when you reboot, the new settings will take effect. You actually don't have to do the compilation and creating a new image file. This is what you would do if you were running it on a separate machine. Okay, so let's have a look at what it takes to actually create an image for the LeMaker Guitar then. So the first thing you want to do is download the particular operating system that you want to be installed on the LeMaker Guitar. The one I chose to download because I want to have something that's going to run NodeRed and be compatible with a lot of the coding and examples I'm using for NodeRed on Debian is the Ubuntu for guitar. The Ubuntu name sounds like it's a variation of Ubuntu, but it isn't. It's actually Debian. If you click download here, you can see there's two versions that you can download, and most of these downloads are available in two versions. One of them is to put onto the SD card, which is a very similar process to the process you use for a Raspberry Pi. The other version, which is this one, is for the EMMC, which is the NAND flash memory that's on the LeMaker Guitar main board, and that's the one that I downloaded. Now I've already downloaded this. You just click download, and there you go. The next thing you need, though, to be able to do this is you need to have the program in order to be able to write it to the DFU, and they have a special one for the LeMaker Guitar. Now, the process for installing onto an SD card or the built-in NAND flash is also available on the wiki pages under the Quick Start. So here's the link here. It's wiki.lemaker.org/lemaker_guitar:"quick start." And what this shows you is some of the peripherals you will need. Obviously, you need a power adapter, keyboard, Ethernet cable. If you're going to write the DFU, which is for the built-in NAND, you're going to need a USB 3 cable or a USB 2 cable. Obviously, if you want it to go faster, then you would use the USB 3 cable. Instructions on how to install the images. This one's talking about how to use the SD card for it. Formatting using the standard SD formatter, which I've done plenty of videos before. Windows 32 disk imager, same as the Raspberry Pi. And then if you're using the EMMC NAND flash, then you need a different tool for that. And here is a link right here on this page to download the tool that looks like this. Now I've already done that, so I'm not going to download it again. And once you've put the guitar into DFU mode, and the way that you do that is you press the ADFU button while you power up the LeMaker Guitar and have the USB plugged into the computer. And this program, when it's running, will automatically detect the LeMaker Guitar and go into the DFU programmer will recognize it and bring it up as an available option. So let me just minimize this for a second, and I will show you this working. So right now my LeMaker Guitar is not in DFU mode. I'm actually going to reprogram it right now in front of you so that you can see what happens when we do this. So if what I'm going to do right now is I'm going to press the power button, the ADFU button, and power up my LeMaker Guitar. So you're probably going to hear a few beeps and things like that while this happens. Okay, it's booting up now. So now that it's done that, you can let go of the ADFU button. You heard the little Windows indication that it had found a new device. And you can see here now that the IHFW burning tool has now detected the LeMaker Guitar. And the next thing you need to do is find the firmware. Now this has already found it here, but if I hit the refresh, it will allow you to pick any other firmware file that you might want to write to it. In my case, where did I put the file here? I put it down here somewhere. Oh, here. It's the Ubuntu for guitar EMMC 1601.fw. So you're going to be looking for .fw files. Okay, and that's the one I used here. And once you've done this, I'll just say replace for that. It gives you an indication here of the one you're going to do. You just click on down, and then it will slowly download it. Now, obviously, you don't want to be powering off your LeMaker Guitar while all this is going on, because you could corrupt it and not be able to get back again. I'm not going to test that theory because I only have one. But anyway, once you've got this downloading, just let it go to completion, and once it's done, it'll power off. Then all you've got to do is then hit the reset button again on the LeMaker Guitar, and it will boot up, and its output will be directed to the HDMI screen, which I will show you in just a second. And it comes up with a standard Linux screen. So from an operating perspective, any one of these that you pick on here have the option for loading onto either an SD card or loading onto the EMMC NAND flash. And the process is for the SD card the same as you would use on a Raspberry Pi, and as you've just seen, the process for using it for the NAND flash is very straightforward. You just need to use that dedicated programmer to do it, and it just works over the USB cable, so no special hardware required, just the app and the image file to send out there. So I'm not going to spend time showing you all about what Debian is, because if you've used a Raspberry Pi or anything else, you'll already know that. What I am going to do is just bring up a couple of images of the pinouts for the LeMaker Guitar and the Raspberry Pi and put them side by side so we can see if they're the same or not, and also the hardware specifications side by side so we can do a quick comparison to see whether LeMaker stands out or not from the Raspberry Pi. So I've just been looking around for a list of GPIO pinouts that would be easy to put alongside the Raspberry Pi pinout, and it's not as easy as it seems. This one is a classic Raspberry Pi GPIO pinout, and as you can see here, things like pin 4, GPIO 4 is on pin 7. For the LeMaker Guitar, because of the way that the chip works and things like that, they are, from what I can see, they're all compatible. And most of the functions that I've actually checked have proven to be the same. So things like the SPI bus, the chip select lines, the I2C, power, ground, and things like that. So you can see here things like pin 7, which is actually GPIO 4. This is actually being labeled as GPIO B18. Now that's because the I/O on the actual CPU is in banks A, B, C, D, etc. So you can see over here you've got things like GPIO B8, but there's another one here which is GPIO C26. So depending on the mode that you're accessing them, you're going to have to figure out what the actual numbers are. But that's no different to what the Raspberry Pi is. You've got your basic GPIO, and then you've got your getting closer and closer to the physical chip. So for instance, some of the Python examples that I have that to flash the LED on and off work quite happily, and they're very compatible with the Raspberry Pi. Other ones that talk to the physical layer, for instance, when you're doing echo and cat to the file system devices, then you have to start doing a little bit of math to figure out which is the correct device. And it's not too hard, but it does get a little bit odd when you first look at it. For instance, 1, 2, 3, 4, 5, 6, 7. This pin 7, which is GPIO B18 in this case on pin 7, actually ends up being pin 50 when you're specifying it using the file system. So you do an echo to the export function and give it the number 50, and that actually ends up enabling GPIO pin 7, but GPIO 4 equivalent on the Raspberry Pi, but on the LeMaker Guitar. So just be aware of that when you're starting to use these devices. I'm not going to start doing examples right here on this little bit of a review, but I just wanted to show you that the way that some of the documentation is presented it can get a little bit confusing just because of the way these pinouts are presented. Now I will be doing a separate video on setting up NodeRed and performing some GPIO with the LeMaker Guitar, but just before I finish this video on just having a look at the basic system for the LeMaker, I just want to show you that there is an extensive set of information for the LeMaker Guitar, and it's basically the same for the guitar and the Banana Pi that comes from LeMaker. So the Banana Pro Pi and the LeMaker Guitar, these examples work the same for both, and you can see there's quite an extensive serial to parallel, analog to digital converters, flash memory, SPI bus, I2C bus examples for talking to different devices in here, telling you how to download the drivers, how to set them up. So you've got C library functionality, you've got Python functionality, using the system file space. Here's the math I was talking about a moment ago. So GPIO A is the GPIO plus the number. If you were on B, which remember I said before that it would be 50 for port B. So that's because it's GPIO B plus 18. So 32 plus 18 gives you 50. and that's what you would use for doing an echo cat an echo to. You'd put 50 in the XX and then pipe it to sys class GPIO export, and that would enable that particular I/O pin on the LeMaker. Anyway, I'm going to go through a lot more of this in a separate video. I just wanted to show you that in case you don't get to watching that other one and you wanted to start playing around ahead of time. So lots of information on the wiki site. So yes, Raspberry Pi versus LeMaker Guitar. Let's have a look at the functionality now. The specifications now before I go, just so that we can see how it stacks up. A quick scan of various documents available, and we discover that the LeMaker Guitar is running at about 900 megahertz by default. Let me just minimize this and bring up a terminal session a second, because if you can actually get it to tell you what the current speed of the guitar is by doing an output from the device's system CPU, scaling current frequency. So if you do that, and it tells you that it is currently running at 408 megahertz, which is pretty slow, but it's a scaling frequency. The way that the LeMaker Guitar works is if it is running under load, then it will increase its CPU speed to match that. If I just come back here a little bit to a file I was looking at before, frequency scaling on the Banana and LeMaker Guitar. So what you can do right now, it's running right down here at the 408 megahertz, but you can see here it can scale up to 1.3 gigahertz if you want it to, but you're going to need a lot of cooling if you do that. The command I just ran was this one right here. The available frequencies, if I just run this one, I'll just confirm that these are the available ones on the guitar. Let's just go back to here and run that command on it. And you can see we're right now running at the slowest, but we can quite easily go up to 1.3 gig. Now, according to this, though, you will need to put heat sinks and things like that on the LeMaker Guitar if you're going to permanently run it up there. If you just allow it to do the scaling, then it's going to take care of itself. So potentially it's got a lot more capability than the Raspberry Pi. I don't think even with overclocking the Raspberry Pi can go up to 1.3. It may be able to, but either way, they're both running a ARM Cortex A7 CPU and nominally both running at 900 megahertz. The LeMaker Guitar has a gig of RAM. The Raspberry Pi has a gig of RAM. The Raspberry Pi only has 4 USB ports on it, and they're all USB 2. The LeMaker Guitar has 1 USB 3 and 2 USB 2 ports. And it has 100 meg Ethernet, the same as the Raspberry Pi does. LCD and camera ports are on there, and so does the Raspberry Pi. Unfortunately, they're not compatible with each other. The pinouts are a little bit different for those two particular devices. The GPIO is the same. The Raspberry Pi is powered by a micro USB connector, whereas the LeMaker has a proper barrel connector for its power. It also has the addition of an infrared sensor and a few additional buttons for doing things like resetting and stuff. Now, one of the biggest advantages that the LeMaker Guitar has over the Raspberry Pi, though, is that right on the motherboard you've got the Wi-Fi and Bluetooth, so you don't need to use any USB ports for configuring, say, a keyboard and mouse and maybe some headphones or something like that. And you don't need to use one of the USB ports for putting in a Wi-Fi dongle either, because it's already built onto the motherboard. The other thing that gives the LeMaker Guitar a little bit of an edge over the Raspberry Pi is the fact that it has hardware support for a lithium-ion battery. So you could just put in one of these 826, the ones from a laptop battery or something like that, or just buy some and hook it up to the Raspberry Pi, and it'll take care of it all. It's got the battery protection, over current, under voltage, over voltage, etc., all built in there. So you just have to hook up the lithium-ion battery to it in an appropriate container, and away you go. The other advantage that the LeMaker Guitar has, of course, is it's got the IR receiver too, which will be very handy if you want to use your remote control for a media center or something like that, a media player. And with the HDMI output, same as the Raspberry Pi, you can either feed it into your entertainment system or your HDMI screen, or you can choose to run it easily off of the LCD display. Now, like the Raspberry Pi, the LCD display does not have a easy way of mounting it to something. You have to effectively clamp it into a shell to constrain the display, but it does seem to be quite responsive, and as we go through some of the other videos, you'll see how I start using the LCD display and things, and I will be printing off a case for this as well, which I'll show you in a future video. The Raspberry Pi is around about $35 to buy. The LeMaker Guitar, so just checking online here, I've gone to Lenovator.com, which is the actual company that sent me my LeMaker guitar with the LCD display. The guitar package here, which is the baseboard, which includes all of the peripherals I was just describing, with the LeMaker Guitar Revision B baseboard and the actual guitar processing board. So the production boards, LeMaker Guitar, LeMaker Baseboard Revision B, is $44 for the package. Now that's about $10 more than a Raspberry Pi, but you do have to remember that this can actually run quite easily faster, but it also includes Wi-Fi, the infrared, the Bluetooth, as well as the capability of using battery backup and things like that. And it also has the 8 gigabytes of NAND flash built onto the board, so you don't need to get an SD card or anything to run it either. The LeMaker Guitar is very, very easy to use and get used to, and you can just get the baseboard and the LCD. You don't have to get all the other peripherals with it, because if you want to use it as a standalone in, say, a 3D printed case, then you don't need SD cards or anything else. And if you've already got power adapters and things, then you're pretty much set. So that's all pretty good. Anyway, as far as an introduction to the LeMaker Guitar, that pretty much wraps it up. I'm going to do some other videos, as I said, on NodeRed, etc., following on from this, because I'm sure that there's a lot of exciting things to discover on the board, and integration with NodeRed is pretty much one of my de facto things that I like to try on all of these different boards, just to see how well it works. Lenovator is the company that actually sent me the LeMaker Guitar, so by rights, give them a look and have a look at their prices. They seem to be quite reasonable. The prices with the kits seem quite reasonable, so if you're interested in getting one, then give LeMaker Guitar a thought at lenovator.com, and I will bring out some more videos shortly showing you how to do other things. The one that's going to immediately follow this one, though, is going to be one on how to get the LCD display working instead of the default HDMI one with the LeMaker Limuntu, which is the Debian instance of Linux. Thanks a lot. Goodbye.